Good morning. Welcome to operating system class. In our earlier discussion, we are talking about directory structures. There, we talked about single level directory structure, multi-level directory structure. Third, we talked about hierarchical directory, that is a tree level or a hierarchical directory structure. So, three items we have discussed. So every item, they do have their own advantages, they do have their own disadvantages. So as far as disadvantages which were highlighted in the first implementation and the second implementation was there is no question of grouping, etc. And the same name of directory structure, directory cannot be given to the same which are at the same entity. So there they went for levels in a granularity, and thereby the problem was overcome. So as far as grouping is going to be concerned, that was addressed in the tree structure architecture. So these are the three ways what were discussed here. Next comes the fourth way and fifth way of organizing the directory structure. One, it is going to be implemented with cyclic graphs, and two, it is going to be implemented with acyclic graphs. One, it is going to be implemented with cyclic graph. Two, it is going to be implemented with acyclic graph. The name is itself in the content, right? If there is a loop which is rotating right in a circular model in a round robin shape, defaultly we are going to call it as cyclic graph. If there is a tree level architecture and the rotation is not going to come to the beginning node in a circular linked list model, then simply we can say it is going to be called as an acyclic model. So as simple as such. So if I am going to call it as a cyclic directory structure, it possesses cycles. If there is no cycles in it, we are going to call it as acyclic. Fine. What is a directory? Directory is nothing but it can contain subdirectories, nor it is going to contain some set of files. What is file? File, it is going to be set of records. What is record? Record, it is going to be called as set of fields. What is field? It is going to have some data which it is going to be stored in form of disk blocks in zeros and ones. So this is what the level of things what we are going to understand. So we do have blocks represented with zeros, one, collection with fields, collection with records, records representing to files, and files representing to a directories. So in our terminology, directory we are going to call it as a folder, right? In Windows operating system, we create a folder. In that folder, we are going to put the files. In an Android mobile phone, we are going to create a folder. In that folder, we are going to put our photographs. So every photograph, we are going to call it as a file there. So this is what we are going to discuss right now. So the architecture, what we are going to tell us, the acyclic graph directories. Acyclic graph directories. So the first item we are going to call it as a root node. After the root node has been derived, next comes the middle node. And this middle node we are going to call, if this is called as a directory, and the middle node we are going to assume it as a subdirectory. First one we are going to call it as a directory. The middle node we are going to call it as a subdirectory. So this is directory structures. They do have their own way of representing the files. These items, they have their own way of representing the files. So now assume that this is subdirectory, this is the root node followed by subdirectory, and thereby you can see this item here. So this is what the circle we are going to form, and the item, it is going to be shared. It is going to be shared between multiple directories, and obviously there is a chain, and this chain is going to be terminated here. It is not cascading up. Similarly, another example which we can see. So in the subdirectory tree structure, a chain was brought here, another chain is going to be brought here, and there is end here, right? There is no question of moving towards the beginning point. There is no question of moving to the beginning point. Therefore, we are going to call this item as an acyclic graphs. We are going to call these items as acyclic graphs. After acyclic graph, we have to represent a cyclic graph. After acyclic graph, we are going to put up a cyclic graph. So how we are going to rise a cyclic graph here is, we do have a root directory, then we are going to have a subdirectories, and subdirectory, it is going to point out to another subdirectory, and thereby you can see there was a link which is terminating back. There was a link which is terminating back. Similarly, you have a granularity where the architecture is moving towards the where it is going to be assumed. So here we are going to assume a cycle is going to be erased. So the reason was we call it as a graph structure. That is why we are going to call it as a cyclic directory. So it is going to represent in a main form one node to another node, another node to another node, and thereby it is bouncing back to the starting location as we do it in circular linked list. The same model, it is going to be represented in a round robin fashion for this graph structure. So there is all about the representation of directories. So as a whole, directory is going to be taken up in 5 items. Item number 1, it is single. Item number 2, it is multiple. Item number 3, it is tree structure. Item number 4, it is going to be called as acyclic. Item number 5, it is going to be called as cyclic. So these are the 5 ways of representing a directory in a file system, right? So that is up to them. After that, now we have a file system structure. We do have a file system structure. And this file system structure, it is going to be implemented in secondary storage devices. So the first and foremost information what we have to get was a file system. It is going to be implemented in secondary storage. This is most important here. It is going to be implemented in secondary storage. Nothing but it is going to be called as hard disk. It is nothing but it is stored as a hard disk. So the 500 GB hard disk to our laptop, the 1 GB hard disk to our laptop, or 32 GB RAM, 32 GB content which is inside this mobile phone. So the memory card what we are going to put it into the mobile phone. So those memory cards are at 1 GB or 1 terabyte of hard disk inside a laptop. We are going to call those items as a secondary storage device. So in this secondary storage, we do have a file system, and this file system, it is going to support the logical address space. It is going to support the logical address space. So how is this logical address space organized? The next question was, what are the constituents of a logical address space? The constituents of the logical address space will be the application programs, will be the logical file system, the file organization, as system, followed by I/O controls and device drivers. So the items which are going to be part of a file system implementation will be, 1, we call it as application programs, 2, we are going to call it as logical file system, 3, we are going to call it as file organization, 4th one we are going to call it as batch systems, 5th one we are going to call it as I/O control, and 6th one we call it as device drivers. Fine. Now let us in detail go in depth with item by item. So first one we are going to have an application programs. So the application programs are the end user communicating parties. They are going to be the end user communicating parties. So user can efficiently use the underlying hardware without any problem. So there it is needing some interface. right? The mobile phone in our hands, if we do have an interface, the Android interface, but behind that, it is just a plastic pieces, it is just a chip which is fabricated in it. We can't directly work on the chip, we can't directly use the memory card, right? It is need to be programmed. So how is it programmed? It is going to have some hardware content over a software, and there we do have a firmware between hardware and software, which it is mingling with an operating system there. So the application programs, it is nothing but we can say a C program, a Java program, or some Word document or a PPT or a PDF. So all these elements, what we are going to use in our day-to-day items, this we are going to call it as application programs. Fine. Second one, we have to understand about logical file system. So as far as logical file system is going to be concerned, CPU it is going to generate the logical address space. So the other name for this interchangeable item, we call it as a virtual address space. And this virtual address space, it is going to be organized by the memory management unit. And this memory management unit, it is going to fabricate a page table. And this page table, it is going to be mapped to the physical addresses. It is going to be mapped to the physical addresses. And these physical addresses, they are going to be maintained by the memory. They are going to be maintained by the memory. The other name of memory, we can call it as a random access memory, right? So CPU generates the logical address space, memory generates the physical address space. Now we need to map this X, we need to match with this Y. That is, we need a conversion mechanism which is done by a page table, that it is going to be in form of pages and it is going to be in form of frames. It is going to be in form of pages and it is going to be in form of frames. So these two are going to be linking the physical address space with the logical address space, which it is going to be taken up as logical file system. After logical file system is going to be taken up, the next item will be the file organization. The next item will be the file organization. Yes. So what are the different ways of file organization? One, we are going to call it as sequential file, and another we are going to call it as direct access file. One, we are going to call it as sequential file, another we are going to call it as random access file, or we are going to call it as a direct access file. So every file system does has its own advantages and it is going to have its own disadvantages. So as far as sequential file organization is concerned, it is going to move sequentially. It is going to move sequentially, one block after another block. One block after another block, data is going to be moved serially, one after the other. So what type of operations we can make? We can make either a read operation or we can make a write operation. Either we can make a read operation or we can make a write operation. To do this read or write, we are going to make file open or we are going to call it as file close. That means if I am going to have a block called as 50, I can move one step towards 49, or I can move one step forward 54th location. So the drawback of a sequential file system is I am at 50th disk block. I want to move to the 95th. I can't go. I have to go one by one, serially one after the other. So until the destination is going to take up, which is an example of linear search model. So that is the thing. It is fabricated in a part of a sequential file system. Now, what is the second way of approach? The second way of approach will be the direct access file system. The second approach will be the direct access file system. Okay, what is direct access file system? So the drawback here was sequential. We are going to access record by record one after the other. The drawback of the sequential file system was we are going to access the records, but we are going to have a more latency, more access time to go to record. So that was the drawback in this sequential file. Therefore, we are going to move to a system called as direct access file. So in direct access position, we can go with read and now we can go with write and now we can go with reposition n. That means now I am going, now I am at 50, then go to 95. That means I can move ahead number of disk blocks at a time. Then reposition from 95 to 150. That is, we are going to move the arm of a disk right from 95th location to 150th location. We are able to move. So all such operations we can do it in a direct access file. So in a mobile phone, we have this MP3 player. So we are listening to one song. I want to move to some 10th song. So directly I am pressing on the 10th song and 10th song is going to be displayed. So from one position, I am repositioning to another position. But if the same MP3 player was using a sequential file, I have to go from first song, second song, third song, fourth song. One song after another song I have to move. That is in a tape recorder model, the old generation time. So that is where we are going to assume it as a sequential file. But in the mobile phone, I can move from one song to another song, which is somewhere in a memory card, somewhere in a cloud. So in this way we are moving. So that is the advantage of what we are going to get in a direct access file system. So we talked about application programs, we talked about the logical file system, we talked about file processing, and the next three items, they are going to be totally hardware structured. So in this we do have this batch processing. So batch processing, it is going to operate batch by batch. First it executes one program. After the entire set of batch of programs are completed, then it is going to update to another set of batch. Another set of batch has been done, then it is going to move to the another set. So in this way, batch by batch, data is going to be moved. Next one will be the I/O control. So how we are going to link the hardware resources, that is a keyboard, a mouse, a monitor, a printer, a scanner. So all these items, they have to be linked up with the CPU, not they are going to be linked up with the memory. So CPU it is going to have a control unit and a arithmetic logic unit, and memory is going to be separate. And thereby we do have some input devices, we do have these output devices, right? So central processing unit, the components will be CPU and ALU. The entire box around the CPU, we are going to call it as a cabinet. So don't confuse. So memory is going to be separate, CPU is going to be separate. It is not that memory was inside the CPU. The entire memory is a separate component, CPU is a separate component, and CPU does has control unit and arithmetic logic unit. And if it is having multi-core processor, Core i3, Core i5, Core i7, then different CPUs, n number of CPUs will be there. So I have purchased a mobile phone, I am going to say it is quad-core processor, octa-core mobile processor. That means there are 8 CPUs in the mobile. So my mobile is supporting octa-core. What is that octa-core? That means there are 8 CPUs in the mobile phone. I am going to purchase a mobile phone which is having quad-core processor. So Qualcomm quad-core. So what is Qualcomm quad-core? That means there are 4 CPUs which are made by a company called as Qualcomm. That's all. So in one chip, in one mobile phone, instead of uniprogramming one CPU, there are multiple CPUs. So that's all. So in this way, we should interpret what was the organization of the CPU and how it is going to be linked up with the input-output devices. So that is what we are going to assume here as an I/O control. After I/O control, every device, if it wants to link up with the CPU, definitely it needs a drivers. So if there is no driver, we cannot connect the content to the CPU. So purchasing a webcam. After purchasing a webcam, if I link the webcam to the CPU, it will not work. When purchasing a webcam, they will give us a CD. So that CD is going to have a software, and that software will give a compatibility between the webcam and the operating system. So the software, what it is going to support to link a webcam to a computer, we are going to call that item as a device drivers. They are going to be called it as device drivers. So I purchase a Bluetooth pin. So obviously Bluetooth pin, when it is connected to the CPU, it will not work. Again, you have to download the drivers from the internet, not install the drivers from the CPU, install the drivers from the CD. Once they are done, then it is going to have a compatibility with the operating system. So the device drivers, they are going to play a major role in the file system. So once they are going to be linked, they can be connected to a file, either to a sequential access or to a random access to do a read operation, read-write operation, reposition operation. So whatever operation is supported by direct file, that can be supported. So the file system structure, it is going to have 6 attributes. One is going to have the interface with application programs. 2, it is going to have the secondary storage implementations. 3, it is going to have sequential file and random file. 4, it is going to execute the things into batches. And 5th, it is going to support the input-output devices. And 6th, it is going to have a support with the device drivers, which support the input-output organization. Right? So these are all the different available file structure contents. So after this, the next point will be the file control block. File control block. So the items inside this file control block will be file permissions, file dates, file owner, file size, data block, and pointers. So, as far as the file control block is going to be concerned, this file control block do have a primitives. One, we call it as file permissions. 2, when the file was created, when the file was modified, not when the file was re-updated. So all those content is going to be recorded in the file date. So what is file permissions? So you can just right click on any file in your laptop, then you can go to properties, and there you can see permissions, read permission, write permission, hide permission, unhide permission. So these are the different permissions over the files. So when I'm going to click that permission, definitely that permission is going to be obeyed by the operating system. I right click a file, then I go into the permission, then I say hide. Then that file will not be available to all the people. Similarly, I go to the menu there, again see that the file option unhide, again the file will be displayed to us. So these are all the attributes which are belonging to the file. That is read, write, hide, unhide, open, close. So these will be the different types of file permissions. So next one, you can try this item also. You create a file and say ABCD, save the file. After 10 minutes, then you open the file and edit it to 1, 2, 3, 4. Then what it shows us when the file was created, when the file was updated. So it gives you difference between first time and second time. So that all is going to be displayed in model of file data. After that, it is going to create file owner group. So when installing the operating system, it will ask what was your name. So defaultly you give your name. Then from next time onwards, you can open Word document or Excel document and see When a document was created, it will be in your name. It will be in your name. So the name will be displayed in the properties. So who is the owner of that file? So who has created it? So that is where we are going to call it as file owner group. Next one, file size. It is going to be in KB, it can be in MB, it can be in GB, right? You click a photograph and photograph, it will be in some 1 MB or 9 MB or like that. You compose an email, it will be defaultly 4 KB if there is very less amount of content. So every file, it is going to have a default size of 4 KB, and based upon the content, that file is going to be of variable size. Next comes the how many number of disk blocks are going to be occupied by a file. How many number of disk blocks they are going to be occupied by a file. So that is where a disk block and number of pointers allocated to that file is going to be designed. So I am going to have a secondary storage device. I do have some secondary memory, and this secondary memory, it is nothing but called as a hard disk. It is nothing but called as a hard disk. It can be C drive, U drive, now it can be the memory card in your mobile phone. So we call those items as secondary storage devices. And how is the file, the photographs, the videos, what we take on a mobile, etc. How are they going to be stored? They are going to be stored in a file system, and that file system, it is going to divide the files into some set of file nodes. It is going to be set of some file nodes, and these set of file nodes, they do have some disk blocks. They do have some disk blocks. So a file system, it is going to support it with file node, followed by inode, followed by super node. So in this way, a node structure is going to be taken up to put the things in a hierarchical or a tree structure, and thereby when it goes to the secondary storage implementation, the items they are going to be called it as disk blocks. The items they are going to be called it as disk blocks there. So these disk blocks, they are going to contain the files, and every file is going to have some property, and that property is going to be mentioned as file control block. So what are the properties of a file? One, it is going to have a file control block. It is going to contain permissions, read, write, open, close. Next, it is going to have date, when it was created, when it was modified. Who is the owner? So the name of the owner who has created that file will be recorded. Similarly, it is 4 GB or 4 KB, 1 KB like that. What was the file size? So if I'm going to say 4 KB, then in that 4 KB, how many number of disk blocks are available? What are the locations? Everything is going to be recorded. So that is the locations here we call it as disk block content. So again, in disk organization, we have tracks, we have sectors, and we do have a file handling which moves the header right from one cylinder to another cylinder. That we'll be discussing later. So as far as this file control block is going to be concerned, it is going to have a file attributes which we call it as file permissions, date, file ownership, file size, and data blocks. After this file control block is going to be taken up, now we have an illustration. We have an illustration. We call it as in-memory resident programs. We call that one as in-memory resident programs. That means how the memory is going to link up the disk blocks, etc. So as we are discussing, as we are going to discuss, so I have a D drive. In this D drive, I am going to create a OS class, and in operating system class, this is what I am going to call it as folder, right? In this folder, I am going to create some unit 6, and again, this is called as a subfolder. And this subfolder, it is going to have some file1.ppt, file2.ppt, etc. So now, first one we are going to call it as disk. This is called as volume. This is called as volume. So folders, what we are going to write, these items we are going to call it as directories. So D drive, C drive, etc. We are going to call it as volume. Folders, subfolders, we are going to call it as directories. So the PPT or PDF files or Java or C files, we are going to call it as files. How are these files represented? They are going to be represented with the file blocks. They are going to be represented with this file blocks. That is file control blocks. File control blocks. So how is CPU relating? CPU is relating with directories, and this directory is going to link to file. File is going to have some disk blocks. File is going to have a disk blocks. So this is the granularity what we have to understand. So D drive, E drive, F drive. It is D drive, it is E drive, it is F drive, it is C drive. Now this entire C, D, E, F drives, we are going to call it as hard disk. We are going to call those items as hard disk. Hard disk is nothing but we call it as some secondary storage. We call it as secondary storage. So you should understand how the memory is going to be organized. We have a hard disk. It is partitioned into C drive, D drive, E drive, F drive. C, D, E, F. We are going to call it as volumes. Every C drive, it can have files, it can have directories. Directories can have some subdirectories, that is folder or by subfolders, etc. We call them as directories. They contain files. So folders, we are going to call it as directories. Files, yes, we don't interchange the name. We are going to call it as files. So files, they are going to be represented in file control block. Files, they are going to be represented in file control blocks. So that is what we call here as a disk blocks here. So file control blocks, it has file name, file permissions, file when it was created, who is the owner, what are the disk blocks, what are the pointers in these files. So those are its, they are going to be part of this file control blocks. So in today's class, we have taken up directory structure, single, tree, multiple, cyclic, acyclic, and we have a detailed discussion over that. Next one, we talked about file system. In this file system, we talked about application programs, IO blocks, IO devices, IO drives, file system implementation, so file organization. All these are going to be the components. Later on, we talked about file control block, and file control block, it is having some relationship with directory system, and file control block has some set of permissions. So this is all the learning what was happened for today. In tomorrow's class, we will be talking about how in-memory resident programs are going to be executed, and thereby we will be talking about how a disk scheduling is going to be taken. So that is all for inputs for today. Thank you for joining. I'm stopping the recording.